operations, I should say. So when you're looking at this first one, instantaneous rate of change, what I would do for that is, I'll do green for the derivative all the time. So instantaneous rate of change, that's code for F prime or derivative or something like that. So as you go through, guys, stop talking please. As you go through questions, you should, boys, right, be like underlining as you go. So like instantaneous rate of change of a position. So think of like meters, you know, think of like feet, okay? So if you're talking about a derivative of a position, that's code for, Landon, what do you think?
For what?
Number one.
Number one, I would say...
Can we pay attention, please? A, velocity. Okay, so this is going to be a velocity. So instantaneous rate of change of a position is a velocity. Okay, possible units for acceleration. So think of acceleration, you're doing, that's position, velocity, acceleration, right? So you're going like, it goes meters, then meters per second because we're doing slope, and then this one would be like meters per second squared. But it says possible units for acceleration. Oh, I used that example. Dang it. Oh, well. What you're going to look for, it's like meters per second squared, right? But another way to think about that would be like F, meters per second. Okay, so that's another unit for acceleration. All right, units for instantaneous, there she is, little deriv of volume, where V is measured in gallons and T is measured in hours. So if you're thinking about derivative, that's a slope. So if you're taking a derivative when you're dealing with gallons and hours, the units are going to be gallons per hour. So this one would be G. Is there any questions so far? Gallons per hour. Okay. Possible units for position. Hopefully that's not an issue. Okay. So length is position. Instantaneous, okay. Instantaneous rate of change. Again, deriv. Maybe I'll just write deriv or F prime, whatever you want. Deriv means instantaneous rate of change of velocity. Ooh. When you take the derivative of velocity, what do you get? Acceleration. Look at you guys know things. Good job. Okay, possible units for velocity. Velocity you can think of as speed. So that one's going to be meters per second. And then, where did I circle F? That was weird. And then units for instantaneous rate of change. And we're talking about gallons per hour, and T is measured in hours. So we're taking a derivative of something that is in gallons per hour. Right? So if we're doing a derivative of gallons per hour, granted we don't have any other options, but it would be gallons per hour. Because if you're doing slope, remember the numerator is like the y, and then the denominator is like the x. And for this is time. So that's why the per hour is like the dividing by the time. So that'd be C. Okay? Not too shabby. So I'm going to start, or actually we'll do these together, and then we'll start letting you try to figure it out on your own. Ooh. All right. So instantaneous versus average. So you have to decide whether each phrase is used in the following problems. It corresponds to an instantaneous rate of change or an average rate of change. So you're going to just put a check mark in what you think. So the things you got to look for is like words that talk about a span of time. That's going to be average. If you want to know at a certain time, that's going to be instantaneous. So like number one, I think is a little more, kind of gives it away a little bit because they're saying legitimately over a time interval. Like they say what just happened there? They're actually saying like legit interval, like in between. So if we're doing in between, that's average rate of change, right? So maybe actually to back up a little bit. So instantaneous would be like the derivative, F prime. Average rate of change, that's just like your slope formula. Because remember when we did like mean value theorem? Mean value theorem is when the instantaneous equals the average. So instantaneous is like straight up, like your speedometer, whereas average is like your average speed over a time period. So for number 1, again, it says interval. Okay, this second one might be a little confusing, maybe. It says after 3 seconds have elapsed. So if they asked you, like, if you start the sentence with, what's the rate of change after 3 seconds have elapsed? That's going to be instantaneous. Okay, so after 3 seconds, so 3 seconds has happened, what is my speed? Okay, they didn't say like during the first 3 seconds, they didn't say like from 0 seconds to 3 seconds, what's happening. You know, they're not referencing an interval. 3, this is like exact noon. So exact value, that's like my speedometer. Like at this value, this is my speed, instantaneous. Okay, so why don't you do 4, 5, 6? Check with your person next to you. See if you get it right. This shouldn't take too long. Okay. All right. So average, instantaneous. So the key word is during, right? During versus after, like right after 3, what's my speed? During the first, like they're talking about during this time. It's an interval. Over a 12-hour period, that's an average because we're talking about an interval. All right, so this one, we're just going to look at units. Okay, so part 3, complete the last column in the following table with the correct units for the derivative of the function given in the first. First row is completed. So for example, okay, so dependent variable, that's like the y. You know, maybe that'll help. But that's like the y, like, or the f of x, or whatever you want to say it, okay? Independent variable is like your x, okay? So it's like, if you're taking a derivative, remember derivative, like, even in like, remember the Lebanese form, dy dx, you're taking the change in y over the change in x. It's just like straight up slope, right? So like, if you need to find c prime, all you do is think of slope and how you would do it, and then you take the units. So you're basically like dividing the units. That's all you have to do. So like if this is, maybe I'll do the colors here. So like if this is your y, right? If you're taking the derivative of it, you're going to take dollars. And then because it's a derivative, you're going to do per. And then you're just going to take your unit for your like x, which is hours. So the derivative would be dollars per hour because you're just basically doing slope. That's all you're doing, okay? So like a of t, a is measured in centimeters squared, so I'm assuming it's an area thing. And then t is measured in seconds. So like a prime of t is measured in, all you have to do is centimeters squared per second. That's it. So with every single problem, I usually just try to figure out what the units are. So then when I'm doing derivatives, all I'm looking at is like, oh, I just divide them, done. You know, like don't overthink about what they're asking. Just look at the what you're taking derivatives of and what are your units for those. Okay. This one, okay, we're dealing with kilograms. So the derivative is going to be kilograms per, come on, cubic meters. So oops, not centimeters, silly. Cubic meters, okay, per meters cubed. This one might like freak you out a little, but you just have to channel your chemistry energy with the unit analysis stuff. It's basically like using fraction rules. So for this one, because it's miles per gallon per miles per hour, like that feels weird, you know? So like you would do miles per gallon, right, first, divided by, and then you would do miles per hour, but this is like really gross looking, like as a unit. Plus, I don't even know what that means. So, just like how you would do like dividing fractions, you do the same thing. You're just going to multiply by the reciprocal and start crossing off some units. So you go times hour over miles, and then you can see how the miles cancel. So this one's like a little on the jazzier side because you've got to like clean up the units and do this little simplifying business, but it's going to be hours per gallon, which is kind of weird still, but we're just going to go for it. So, yeah.
So, like, in that last problem,
Yeah.
hours and gallons are both last, and then that's what's used. Is that always gonna happen that way?
Yeah, the way it's set up, yeah. But that's more because of fraction rules. Yeah. Yep,
Is hours per gallon not the same as gallons per hour?
correct. Yep, not the same. It's super weird unit if I'm being honest, but that's what it has. All right, so this is like getting you warm. Do you feel warm? Your brain's warm? Okay, because this is the juice, is this stuff. Because what they're going to do on F or Q is they're going to ask you, how does this question, or figure out this value and write what it means in terms of the problem. And you can't talk like mathy. You have to be like talking to a person that doesn't know math, like normal language. So it's like, you're going to use words like decreasing a lot, or you're going to say rate of change. You're not going to use a negative sign. You're not going to say negative for a rate. You're going to use a different word for it. So like this first one, V of T gives the volume of the water in a tank in liters after T minutes. So the first thing that I like to do for this is I like write arrows on this, and V is volume liters. I'll write liters. V is liters, and then T is minutes. Like I'll do this on an F or Q and be like T, like I'll write the unit name for it, okay? So then when I'm filling in these blanks or getting used to like how I'm supposed to say this, like V of 3 equals 20 means that after, so then the T is the 3, right? So then I just say 3 minutes because that's the unit for it, So after 3 minutes, there are, and then 20 is like the V value. So you write 20 and then you just look at the unit, liters of water in the tank. So pretty simple. I mean, you guys have been doing that before. But now when we're talking about a derivative, okay, so this derivative business, you do kind of the same thing where it's like the time didn't change. Like this 3 is still going to be minutes, like, so after 3 minutes, the volume of the water is, now this is the thing, like you're not going to, you have to explain negative things. Because if you say the volume of the water in the tank is negative 2 liters per minute, people are like, what are you even saying? Like talk like a normal person, So like with this negative piece, that's where you use a derivative word. So like decreasing. Decreasing is a derivative word. It's talking about it being negative. So if it was positive, you would say increasing, okay? So you'd say it's decreasing at a rate of, and then this is still your, like the Y kind of, but it's a derivative, so 2 liters per minute. So you're still doing that fraction piece. So maybe I'll just do one more and then have you guys try the rest. So this next one is area of a surface of an oil slick in square kilometers after T hours. So same thing. Write in A is square kilometers. So I'll go kilometers squared. Because then I just can reference it as I go, right? And then I've got T is hours. So that's just like reading through the question, right? So then now when I'm writing out the stuff, A of 24, that's 24 hours, right? So it means after 24 hours, the area of the surface of the oil slick is, and then you say 17, because that's the number, and then you just look at the units, kilometers square, or square kilometers. Okay. Now for the derivative, that's where you want to make sure you're using like that derivative word, decreasing, increasing kind of business. So for this one, so after, again, this is still time, that hasn't changed. So you're going to say means that when, 5, and then look at the unit hours, have elapsed, the area of the surface of the oil slick is, now we're doing a derivative, so we have to include a derivative word into it. And because it's positive, you're going to say it's increasing at a rate of 4, and then you just look at your units and do like the slope thing. So you're going to go kilometers squared per hour. Any questions? So see how you do. Do 2, 3, 4, and 5. Work with your people and there's bigger openings and see how you can get it. I think you can. You guys can work together too, P.S. I don't want to. The rest through 5. So you're doing 1 through 5, remember. So on the next page. Do them all?
Use drain.
Oh my god, it's rain.
Number 5 does not give me enough room.
Because it was the rate. So the rate. Like what it said, the rate of decreasing at a rate of.
You guys are faster at writing. I also had to do all the colors. Okay. All right, number 2. So, it means it costs $140. Don't put the dollar sign at the end, that's embarrassing. Okay, instead of the beginning. You guys know that, right? To dig a hole that is 20 feet deep. So this one was kind of weird because it started with the cost. So I don't know if that threw you or not. And then G prime of 20 means that when the hole is 20 feet deep, the cost is digging is increasing. So notice like both of them are like cost of digging. What makes the derivative sentence a derivative sentence is the word increasing at a rate, of $5 per foot. Okay, the second one, this one was weird because it was like already kind of like a rady unit, So I wrote it out and then it says means that after 2 seconds, the acceleration is -6 centimeters per second squared. Okay. Now for this one is saying, so after 7 seconds, the acceleration is decreasing. So notice this, like this language is still the same. The increasing is decreasing, is what makes it a derivative. Decreasing at a rate of 3 centimeters squared per second. Okay, yeah.
Why is seconds not square in the box?
Say it again.
Why do you not, where it says like, means that after 2 seconds, why is
Yeah.
it not square?
Because T is just plain seconds.
Oh,
Yeah.
Can you write, is decreasing by a rate of 3 centimeters per second cubed?
Per cubed, I don't think they mark it wrong, but it's weird. Because you don't really, because you're talking about how acceleration's changing. So per cube means, I would just do per second, but I don't think they technically mark it wrong. This one, okay, so in the year 1990, because it's saying after 1950, the amount of people in the world was 5.3 billion people, right? And then the derivative again, in the year 2010, the amount of people in the world is increasing at a rate of this many billions per year of people per year. And then last but not least was after 10 seconds, The rate of oil flowing into the tank is 3 pints per second. So I'm literally rewriting the rate in pints, you know, like the rate of oil flowing. Like I'm reusing the words in the sentence. And then after 6 seconds, the rate of oil flowing in the tank is decreasing at a rate of pints per second per second. Again, per second squared is kind of weird because you're not really talking about straight up acceleration. You're talking about a rate of something. So they usually use the language per second per second. Any questions? Okay. Yeah. So I guess rule of thumb is make sure your units are under control. And the way you start all these is very similar. You're still using the same, like, what does my R stand for? And what makes it a derivative sentence is this decreasing at a rate. Yeah.
So the rate is decreasing at a rate?
Yep. Yeah, so the rate is decreasing.
Alright.
Yeah. All right, last thing is writing it backwards. So now you have the stuff, and you have to write it as a derivative. So they have all these words here. So they're saying that V is the volume in liters. So V is liters, and then time, T is minutes. Okay, so you're gonna read them all. And then try to figure out what the derivative statement is. So when 7 minutes has passed, so there's your T, the instantaneous rate of change, that means deriv, rate of water in the tank is 12 liters per minute. Okay, so that's going to be V, because we're talking about the liters, it's an instantaneous rate of change after 7 minutes. And that's going to equal 12. So V prime of 7 equals 12. Okay. Okay, number 2 might get you, maybe. This one is saying after 2 minutes, the rate at which the volume of the water is decreasing is 5. So 2 minutes is time, so at least we got that. And then they're saying rate decreasing, right? So that's derivative stuff. So this is going to be volume, derivative, time doesn't change, that's why I like that one. But then they said decreasing, so that means you have to write negative 5. Did you get that? Right, so negative 5. And then T equals 10. So you're going to have 10 in there. We're doing rate increasing, you know, so that's all derivative stuff is for. Okay, so that's it. Your homework's a worksheet. There's a lot of